So, thank you. Hello, everybody. I'm very glad to have today the talk titled Consideration on Holdout Bound Token from FAPI implementer's perspective. Oh, sorry. Before my talk, let me introduce myself briefly. My name is Takashi Norimatsu, working at OSS Solution Center, Hitachi Limited, Japan. I've been engaging in providing support services about open source software and also contributing some features to also OSS. The recent works are that contributing W3C web authentication support to Keycloak, the identity and access management open source software. Also, contributing financial grade API security profile support to also Keycloak, but not yet completed. So today's topic is about holder of key bound token. So today's talk consists of the following three parts. At first, I would like to describe what is holder of key bound token is, why can be used by the several kinds of OAuth-based security profile. And I would like to introduce sender constraint token concept as an alternative of holder bound token concept. Because both holder bound token and sender constraint token can prevent improper resource access by the malicious entities who can hold or steal others' token. So this kind of the characteristics seem to be important, therefore might be required by some kind of security profiles. Then after considering the characteristic of each method for realizing sender constraint token, I would like to propose appropriate way of realizing sender constraint token in OAuth2 protocol in practice. So move on to the first part. Holder of key bound token is a token that is bound with the public key. It can be used to prevent improper resource access by malicious entities who can hold or steal the other's token. Because only the entity holding a private key corresponding to public key that is bound with the token can exercise this token. So other entities cannot exercise this token. To create this holdability bound token, the requester of this kind of the token need to demonstrate proof of possession of the private key corresponding to public key that will be bound with the token. Then the issuer of this token needs to bind the public key sent from the requester with the generated token. In the case of self-contained token, the issuer may put public key related information onto the token itself. In the case of reference token, the issuer may keep relationship between the public key and the generated token. So to use this holdout rebound token, the sender of this token for resource access need to demonstrate proof of possession of private key corresponding to public key that was bound with the token. Then the receiver of this token needs to verify whether the public key bound with this token belongs to the proof of possession proved private key by the sender. If so, the receiver of this token can conclude that the sender of this token is the requester to which the issuer actually issued this token. So in the case of the OAuth2 protocol, today I'd like to only consider the authorization code grant, but can treat both confidential and public client, and pick up the OAuth code refresh token and access token to be holdout bound. Each token has its own characteristics. So the table shown below describes the difference between the characteristic of each token. For example, the OAuth code and refresh tokens audience is OAuth server, while in the case of the access token, generally speaking, the resource server. And we can request the refresh token and access token to OAuth server directly. But in the case of the OAuth code, indirectly via end user's browser. So to realize this holdout bound token, I found out the following major three standard technology. MTLS, OAuth2 Mutual-TLS, client authentication and certificate bound access token. And also B, the OAuth2 token binding, and the DPOP, OAuth2 demonstration of proof of possession at application layer. So each method has its own characteristic. So the table shown below describes the difference between the characteristic of each method. For example, the MTLS and the DPOP can only treat a refresh token and the access token to be holder of the bound, while OSB can treat OAuth code refresh token and access token to be holder of the bound. Then the MTLS and OSB both leverages TLS, while DPOP not. And the MTLS only requires the standard TLS, while OSB requires standard, not only standard TLS, but also its own TLS extension. Then by considering the characteristic of each method for realizing holdout bound token, and also considering the characteristic of each token to be holdout bound, I will conclude that the refresh token and access token can be holder of the bound in practice. However, I think the authorization code cannot be holder of the bound in practice because only the OSB can theoretically realize holder of the bound token, but it seems not to be in practice because the OSB seems not to be widely adopted currently, and the OSB uses PIXI mechanism for realizing holder-driven OAuth code. So, and this OAuth code seems not to be bound with client's public key directly. And it seems to be difficult to demonstrate proof of possession of the private key securely by the client to the auth server via end user's browser. So if we are interested in or want to prevent improper resource access by malicious entity who can hold or steal other token. How about not only considering the holder-driven token, but also considering sender constraint token. So the sender constraint token is the token that can be only be exercised if the sender of this token is the specified entity. It can be used to prevent improper resource access by malicious entity, the same as the holder-driven token can do. Then, to realize this sender constraint token, I've found out the following three methods or technology. Holder-driven token I've just mentioned before, and client-bound token, and FAPI proof key or code exchange that is specialized for the OAuth code. So please note that the client-bound token, this terminology is not the official. I've not found out official terminology, the appropriate terminology to describe this concept, so that today I'd like to use this word tentatively. So client-bound token is the token bound with the specified auth to client. It can be used to prevent improper resource access by malicious the client entity, because this token can only be exercised if the sender of this token is the specified auth to client. So to create this client-bound token, we need to consider the following 3 points. Client authentication, to clarify which client requests the token, and client representation, to bind an authenticated auth to client with generated token, to show afterwards to which client the issuer of this token issued this client. Finally, the message integrity and authentication, to make this token tamper resistant and can be checked out who issued this token afterwards. So to use this client-bound token, message integrity, we need to consider the following the same 3 points. The message integrity and authentication, to clarify whether this token was not tampered, not forged, and clarify whether this token was issued by legitimate auth server, and the client authentication, to clarify which client sent this token. Finally, the client representation, to clarify to which client the issuer of this token had issued this token. So, if the authenticated auth to client is the same client represented by this token, The receiver of this token can conclude that the sender of this token is the one who requested and has been issued by the issuer of this token. Then, to realize the 3 point I've just mentioned earlier, I found out the several standard technologies. At first, the client authentication. I found out the major standard technology. The MTLS I've just mentioned before, and private key JOT defined by OpenID Connect Core, and client representation. In the case of the self-contained token, I found out the following two standards using client ID claim and AZP claim. In the case of the reference token, I found out the one standard using client ID claim as a field of response from OAuth token introspection. Finally, the message integrity and authentication, we can use JSON Web Signature. So, both holder-key token and the client-bound token can prevent improper resource access by the malicious client, malicious entities. But each method has its own characteristics. So here I would like to describe the difference between them. At first, the OAuth to client authentication. We need not to do OAuth to client authentication for realizing holder-key bound token. While we need do the OAuth to client authentication for realizing client-bound token. Considering that point, both OAuth server and resource server are applicable receivers of holder-bound token, while only OAuth server can be applicable receiver of the client-bound token because, in my opinion, generally the resource server cannot do OAuth to client authentication by the same manner used by the authorization server. But however, the resource server can do that. So for example, the administrator controls both OAuth server and resource server. Then both OAuth server, OAuth server and resource server can be applicable receiver of this client-bound token. The next point is Indirect Sender Constraint Authorization Code request. Sender Constraint Authorization request, code request. I've just mentioned earlier, it seems not to be possible in practice if we use holder-bound technology. But it seems to be possible if we use client-bound token technology. However, we need to consider the following 1 point shown below: the message integrity and authentication, or the client identity sent from the client to OAuth server via end user's browser indirectly. To accomplish this point, I found out the following three standard request object, defined by OpenID Connect Core and JAR JOT secured authorization request, and finally OAuth 2 pushed authorization requests. Finally, so we might better to pay attention to the following one point if we use MTLS method for realizing holder-ability bound token. The validity of holder-ability bound token by using MTLS method can be affected by the life cycle of the certificate, whose public key is bound with this token. To clarify this point, let's consider the situation that we client use MTLS method for realizing holder-ability bound request and access token. But the existing certificate whose public key bound with those tokens expired, so that this client start using the new issued client certificate. And this client want to access the resource by sending holder-ability access token to resource server. In that case, this request fails because the resource server judges this holder-ability access token became also invalid due to existing the old bound certificate being expired. So this client may try to refresh tokens by sending holder-ability bound refresh token to OAuth server. But also this request fails due to the same reason. Then this client needs to do again the authorization code grant, which may require end users re-authenticate and authorize their resource access, which may annoy the end users. But if we use client bound refresh token, in this case, this client need not to do again authorization code grant, so which may not annoy the end user, I think. So finally, I would like to pick up proof key for code exchange as an for the method for realizing sender constraint authorization code. This is specialized for the authorization code. The way of preventing the improper entity from getting the victim's token in return for the victim's code, authorization code. It can be used to prevent the improper usage of OAuth code by malicious entity, because only the client knowing one-time use only secret can get their token in return for their authorization code. The other entities cannot get the token. Then, considering the characteristics of each method for realizing sender constraint token for OAuth code refresh token and access token. This table that shows the sender constraint token support in OAuth2 protocol by each method in practice. You can see that several methods can support several token to be sender constraint. So the next question is, what is an appropriate way of realizing the sender constraint token, a sender constraint OAuth code, refresh token, access token in each type of confidential and public client? These two tables shows my proposal of the appropriate way of realizing sender constraint token in OAuth protocol for each confidential and public client. Please refer to the upper tables showing for the confidential client. I conclude that OAuth code and refresh token might be better to be client bound, while in the case of the OAuth access token, it might also be preferable for realizing client-bound access token, but if not, we can use MTLS method as first option and debug method as second option for realizing holder of key-bound access token because OAuth code and refresh token are both OAuth code refresh tokens issuer and audience is the same authorization server, and authorization server can do OAuth to client authentication. So we can use the client bound the method for each OAuth code and refresh token. I think so. Then for the access token, generally speaking, the access tokens audience is resource server, and the resource server generally cannot do the client authentication the same manner as OAuth server. Therefore, instead of using client bound method, we can use holder key bound method for sender constraint token. Then, I think MTLS method might be secure than compared to default method because the MTLS can leverage the TLS layer and its security properties. Therefore, I think so. For public client, please refer to the tables below. Pixie is only, I think Pixie is only the viable option for the sender constraint OAuth code. And for refresh token and access token, we can use MTLS, the first option, and developer second option for realizing the refresh and access token to be sender constraint. Because the public client cannot support OAuth to client authentication in its nature. So instead of using client bound token method, we can adopt holder bound method. Finally, at the beginning of my talk, I've told you that I'm contributing to the Keycloak, the FAPI Security Profile support. So these tables show the sender constraint token support by Keycloak. Generally speaking, I think the current Keycloak has already covered the major ways of sender constraint, OAuth code, refresh token, and access token in each type of confidential and public client. In this talk today, I've talked about at first holder bound token, and after that, I've introduced a sender constraint token concept as an alternative of holder bound token concept. Both can prevent improper resource access by malicious entities who can hold or steal others' token. Such kind of the characteristics might be required by OAuth-based security profile. And considering the characteristic of each method for realizing sender constraint token and the token to be sender constraint in OAuth2, I have proposed an appropriate ways of realizing sender constraint OAuth code, refresh token, and access token in each type of confidential and public client. So that's all for my talk. Thank you very much for your listening.